Okay, Assalamualaikum dan salam sejahtera. So today we continue our discussion on our tutorial. So we are going to discuss a tutorial for idle flow number 10. So first you need, the question is, what is stream function? A velocity in two-dimensional flow is phi equal y plus x square minus y square, and determine the stream function of this flow. Okay, so means that you need to know how to derive the stream function, which is psi. So this is the stream function from what you have here, which is phi, the velocity potential. And then we have a question like this one: a uniform flow with a velocity u meter per second flow over a cylinder with vortex strength gamma. Show that the lift force per unit length can be written as FL equal rho u gamma, where rho is the fluid density. And B here, a circular cylinder, 3 meter in diameter and 20 meter long, is rotating at 180 RPM in counterclockwise about its axis. Wind flowing at 12 meter per second over the cylinder in the negative x direction. By assuming 92% of efficiency is developing circulation from the rotation, determine the lift force and the location of the stagnation point. The air density is 1.2 kilogram per meter cube. Sketch the flow lines clearly. Okay, for the definition of streamline and so on and so forth, I hope you could read from your textbooks, because I already explained about the streamline, and I hope you could remember the definition of streamline is stated in textbooks. I will not mention here. So let's say we want to answer the second question, which is we have the value of phi here. So, and then from the value of phi here, we need to determine what is the psi. Okay, this is the final answer. So, what you need to know is you need to know the Cauchy-Riemann equation. And from Cauchy-Riemann equation here, we know that d psi over dy is equal to u. And it is also equal to d phi dx. And the definition of v here as shown here. So, and then so let's say we start with d psi dy first here. So let's say d psi dy. So and then we substitute the value. It is equal to d phi dx. So we substitute the value of phi here. So that's why you have here d over dx with y plus x square minus y square. And then the answer is 2x. So and then if we integrate the value of the psi, so here what you do is you just rewrite as d psi dy is equal to 2x. Okay, so and then we integrate. First we bring the value of dy to the right hand side here. Okay, so and then we integrate both sides. So finally we have psi, it is equal to 2xy plus fx plus c. So bear in mind that here c is the integer, the constant for integer, and fx here is actually the constant when we do the integration to dy. So and then we substitute the boundary condition. So we could say that psi is equal to 0, and then if x and y is equal to 0, then we will have c is equal to 0. And finally we could write our psi for x direction is 2xy plus fx. So and then what we need to do is, so we do from the velocity v. So if you could see here, we are doing our calculation on this side. So then we need to use this element also to continue our calculation. So what we do here is, as stated here, we have negative psi dx. It is equal to dy for phi, and we have it is equal to 1 minus 2y. So and then if we do the same steps, so we integrate both sides. So we have psi, it is equal to 2xy minus x minus fy. So what I want to show here is there is another method to get the final terms for psi. So by comparing equation 1 and equation 2. So we have this equation. So if we see we have psi here is 2yx plus fx. So we have another psi is 2yx plus fx. So, and then we have another psi here, which is 2xy minus x minus fy. So here we assume that maybe this fy, this function of y is actually this term. And then this fx is actually this term. So, and then finally we could say that the final psi here, it is equal as 2xy minus x. So this is another method, a little bit faster, but if you don't have any confidence from using this method, you could do the derivation, start from this term. So means that from this term, what you need to do is, because we are using this one, so it is better, it is good for you to do the derivation in terms of this. So means that you start here with d psi over dx. So d psi over dx, and then you could, it is equal to negative v, and it is also to negative d phi dy. Okay, I hope you could try this at home. And then this is the calculation to prove the leaf force. So we know that leaf force is actually force in y axis. So mean if you have an object here, so when you have force lift this object upwards, so we call this as a leaf force. So a drag force is actually a force which is act on x-axis. So from our previous calculation, we could have these terms. So I hope you could see our previous notes. Okay, so and then if we get this term, so what we need to do is we need to integrate from 0 to 2 pi, because we are focusing on cylinder or rotating cylinder. So and then when we do the integration, so the idea is we need to change the term of sine theta here into this term. So and then we do the integration, so the limit is 0 to 2 pi, and then we could have this term. So and then finally we could say that lift force here is actually equal to rho u and gamma. So in certain textbook, they will use FL as lift force, and they will use FD as a drag force. So let's say if you want to calculate the lift force that actually occurs on a certain object, so you may use this equation. So FL is equal rho u and gamma, and then gamma can be calculated by using this equation, 2 pi omega r square. In our previous tutorial, I already show you how to prove which gamma is equal to 2 pi omega r square. So and then another thing that you should know is u here is the linear flow. So and then so it is in linear unit, so which is in meter per second. However, in gamma equal to pi omega r square, omega here is actually the rotational speed. So means that the omega here is in radian per second. So means you need to know how to convert from linear to rotational speed. So and then the common equation is u is equal to r omega, and it is equal to pi dn over 60. So here the n here must be in rpm, in rotational per minute, because in this equation we divide into 60. Okay, this is the common common equation. So from what we have here, for example, we have diameter is 3 meter, length is 20 meters, and rotational speed is 180 rpm. So, and then we have efficiency 92%. So I think in fluid mechanics 1, you already know about the efficiency. Efficiency means how efficient or how good certain system receive certain energy. So awak kena faham efficiency membawa maksud kecekapan, membawa maksud bahawa berapa bagus sesuatu sistem menggunakan input untuk menghasilkan output. Kerana efficiency pada asalnya adalah output dibahagikan dengan input. So maksudnya kalau awak ada duit RM10, okay, sekiranya awak boleh membuat penjimatan atau boleh saving sebanyak RM1, oleh itu membawa maksud efisiensi awak mungkin 10%. Efisiensi penyimpanan lah, tapi efisiensi perbelanjaan mungkin 90%. Itu yang paling mudah. Okay. Kecekapan awak membelanjakan duit. Okay. Ada setengah orang mungkin ada RM10 tetapi tak tahu nak beli apa. Sampai certain masa mungkin ada tinggal RM9.20 ataupun RM9 saja. So maknanya kecekapan dia membelanjakan tu hanya 10%. Okay. Maksudnya output over input adalah efficiency. So apa yang dimaksudkan dengan efficiency di sini ialah membawa maksud di dalam soalan dia beri efficiency tersebut sebagai by assuming 92% efficiency in developing circulation. So maksudnya circulation itu hanya mempunyai efisiensi 92%. Oleh itu di mana kita masukkan pengiraan efisiensi itu, okay, bolehlah kita masukkan di dalam pengiraan gamma. So kita tahu gamma sama dengan 2 pi omega r square. So kita masukkan dan kita darabkan 92% di sini. Kerana di dalam soalan mengatakan the efficiency is 92%. So saya harap awak faham 92% di sini membawa maksud 92%. Jadi setelah dikira, so we know that gamma here is 245. So and then we substitute into the equation of lift force. So and then what you should know here, this equation is actually for 1 meter unit width. So maksudnya equation di sini hanyalah untuk mengira lift force untuk setiap lebar 1 meter. So from question we know that we have 20 meter long. Okay, awak kena faham, you should understand the question. We have a circular cylinder here. So and then in 3D you may draw like this. So we have a radius here. Okay, kita ada radius di sini dan di dalam pengukuran kita akan define jarak ini sebagai length. Okay, tetapi sekiranya kalau kita melukis secara normal seperti ini, oleh itu nilai length di sini akan membawa maksud lebar, width. Okay, so jadi saya harap awak dapat imagine. Oleh kerana we have 20 meters length here, so means that we need to multiply with 20 because we want to calculate what is the lift force act on this 20 meters long cylinder. So the answer is 70.6 kilonewton. Then we need to calculate what is the stagnation point. So when you calculate the stagnation point, so the rule of thumb is we must know that at stagnation point the velocity is equal to 0. So and then in our notes we already discussed that in rotating cylinder the velocity is u theta will have certain value, but ur must be equal to 0. So and then we from Cauchy-Riemann equation, I think you could do this. So you have the value of psi, and then we have a Cauchy-Riemann equation, and then you could calculate the value of ur and u theta. and the value of u theta will equal like this one. So and then to know the location of stagnation point means you need to know what is the angle or what is the value of sine theta. So and then you know that from this calculation, when you substitute all the things, you will have it is negative 1.08, and you already know that sine and cos will have maximum value of 1 and minus 1. So means that if you get negative 1.08, so mean this value is actually cannot be solved by using this equation. So it means that the stagnation point is not on the cylinder surface. So sekiranya awak mendapat nilai lebih daripada 1 atau lebih daripada lebih besar daripada, lebih kecil daripada negatif 1, so membawa maksud bahawa stagnation point tidak berada di atas silinder. So oleh itu saya harap awak dapat melukis gambar rajah seperti ini. Maknanya kita beranggapan bahawa ada aliran dan dia berlanggar di sini menyebabkan dia berpusing seperti ini, dan akhirnya dia akan keluar balik di sini dan seterusnya. Okey, dan saya harap di sini awak boleh melukis macam ini dan seterusnya. Saya harap di dalam lukisan ini awak boleh menulis silinder dengan betul. Awak boleh melukis titik tengah, awak boleh melukis arah aliran silinder, putaran silinder, dan awak boleh melukis anak panah untuk aliran linear. Kerana ini menunjukkan bahawa awak benar-benar faham dari mana linear itu bergerak, daripada bagaimana silinder itu berpusing dan sebagainya. Okey, seterusnya. So this is tutorial for ideal flow 11. Water flows at flat surface at 3 meter per second as shown in figure below. A palm draws off water through a narrow slit at a volume of 0.03 meter cube per second per meter length of the slit. Assume that the fluid is incompressible and inviscid and can be represented by the combination of uniform flow and sink. Then locate the stagnation point on the wall, point A. Determine the equation for the stagnation streamline. How far above the surface H must be the fluid be so that it does not get sucked into the slit. So di dalam in this question, it gives you one situation where, for example, you have a flat plate here. So and then on this flat plate, you have one small hole, and this small hole is sucking your liquid. So means that at least you could imagine. So imagine like this. So oleh kerana kita ada satu sink di sini yang akan menyedot masuk. So jadi kalau ada molekul, dia akan travel dan akhirnya dia akan disedot masuk. Ada molekul lagi di atas ini yang akan boleh melepasi sedikit tetapi disedot lagi. Di sini dia akan bergerak lagi dan dia akan masuk lagi. Tetapi ada satu molekul yang mungkin kedudukannya 50-50. Dia bergerak, dia ada kemungkinan di sini sama ada disedot ataupun ada sebagainya yang boleh bergerak semula ke sana. Okey, boleh dapat idea? Okey, so selepas daripada ini, molekul ini akan bergerak di sini dan akhirnya akan bergerak ke sana. Dia kerana apa? Kerana di dalam ideal flow, kita kata tidak ada kemungkinan untuk molekul itu cross the streamline. Maksudnya bergerak daripada sini, melompat masuk ke sini. Tak ada. So dia tidak ada molekul yang boleh cross the streamline. Okay. So jadi di sini saya harap dapat imagine bahawa apabila ada satu molekul di sini yang bergerak dan akhirnya kita kata kemungkinan berlanggar di sini dan akhirnya menyebabkan ia masuk di sini, dan ada kemungkinan molekul yang lain akan bergerak ke sana. Oleh itu kita boleh beranggapan bahawa at point here, so we call it as point A here, so we could label it as a stagnation point. Okay, walaupun fenomena ini tidak diajar di dalam basic flow pattern kita belajar source campur dengan linear. Tetapi dalam soalan ini kita lebih kepada combination of linear, which is uniform flow, and sink. So walaupun tidak diajar, saya harap awak dapat boleh menyelesaikan kerana step yang digunakan adalah sama. Okay, so the idea is, saya tak terangkan, saya cuma beri yang ini sahaja rasanya. Oleh itu, idea dia ialah, idea dia sama sahaja, cuma kita kena mergekan sink dan linear flow, dan awak carilah nilai H adalah dengan menggunakan idea asymptote. Okay, saya terangkan di sini. So, oleh kerana kita ada sink di sini, kita ada sink dan kita ada linear dalam keadaan ini, apa yang perlu awak buat? Awak buatlah psi combination sama juga dengan linear. So, kita ada UR sin theta. Oleh kerana dia dalam keadaan positif, kita beri dia positif. Dan kita ada sin, kita ada minus m theta over 2 pi. Kemudian kita imagine bentuknya adalah half body Rankine, by right? Okay, so dia ada stagnation point di sini. Dan dia bergerak ke situ lah. So, jadi kita anggap ini adalah stagnation point. Okay, kemudian daripada stagnation point ini, apa yang perlu kita buat ialah kita kena tentukan, okay, stagnation point, okay, satu cerita, tamat. Kemudian kita perlu ingat bahawa nilai psi combination di sini sebenarnya masih lagi tidak diketahui sama dengan kosong atau ada nilai lain. Jadi macam mana kita nak tahu nilai psi combination ini sama dengan kosong atau tidak? Kita kena masukkan apa-apa koordinat, apa-apa titik yang ada di atas combination ini. Okay, yang paling mudah kita masukkanlah stagnation point di sini. Kerana apa? Kerana nilai jarak ini kita ketahui, maksudnya kita anggap jarak ini adalah R. So kita tahu jarak ini adalah R dan theta di sini adalah kosong. Oleh itu kalau kita masukkan nilai sin kosong di sini dan juga kosong di sini, oleh itu kita akan dapati bahawa psi combination sama dengan sifar. Oleh itu awak boleh menulis UR sin theta sama juga dengan tolak m theta over 2 pi sama juga dengan psi combination sama juga dengan kosong. Okay. So kalau awak lihat di sini, sebutan ini kita boleh tukar menjadi kosong sama juga dengan UR negatif UR sin theta campur m theta over 2 pi. So jadi sebutan ini seolah-olah sama juga dengan linear yang bergerak daripada kanan ke kiri kerana dia negatif, dan plus m theta over 2 pi adalah source. So jadi yang sebenarnya awak menggunakan rumus yang sama ketika kita belajar gabungan antara linear dan source. Okay. Itu satu. So kemudian soalan dia, okay, determine the stagnation streamline. So awak boleh refer kepada tutorial yang lepas berkenaan dengan linear campur source. Cuma yang saya nak bincangkan ialah how far above the surface H must the fluid be so that it does not get sucked into the slit. So yang ini awak kena faham bahawa semakin tinggi kedudukan H ini menyebabkan semakin lemah daya tarikan sink. Oleh itu akan ada satu kedudukan di mana molekul akan bergerak, molekul akan bergerak dan akhirnya seperti yang saya katakan tadi, dia 50-50. Ada yang disedot dan ada yang bergerak. Okay, so dengan beranggapan ini adalah stagnation point S. Okay. So jadi kita boleh mengira kedudukan nilai H di sini dengan beranggap ini adalah Y asymptote. Okay, so awak boleh tengok rumus ataupun tengok nota berkenaan dengan pengiraan Y asymptote. Bagaimana kita nak mengira Y asymptote? Mudah sahaja. Okay, kita anggap bahawa kita ada half body Rankine seperti ini. Okay. And then kita ingin mencari nilai H di sini. Oleh itu kita beranggapan bahawa theta mestilah ini theta. Semakin belakang nilai menjadi semakin tinggi. Betul kan? Maksudnya nilai theta akan menjadi semakin tinggi. Ini theta 2, theta 1. Oleh itu, apa yang awak masukkan, awak bolehlah menggunakan side combination. Kemudian apa yang awak buat, awak kena masukkan apabila theta menghampiri nilai pi. Okay, kerana apa? Maknanya nilai H ini menjadi maksimum apabila nilai theta di sini, okey, betul-betul kita kata nilai yang menghampiri nilai pi di sini. Okey, boleh dapat So jadi saya harap awak dapat cuba untuk menyelesaikan masalah ini. So jadi saya dah beri awak hint tentang yang ini, saya harap awak dapat menyelesaikan masalah. Okey, seterusnya kita melihat tutorial nombor 12. A stream function is given as psi equal to x square minus y cube at point P 31. Determine the velocity of fluid flow. The condition of the flow field is the rotational or irrotational. So soalan ini lebih kepada basic knowledge about ideal flow. So kita first we need to derive from Cauchy-Riemann equation the velocity of fluid flow. So we know from Cauchy-Riemann equation, so we have this one. So we have 2 here. So we substitute the value of y and x here with the coordinate given in the question. And finally, we will get the value of velocity. However, you must know that the value of u and v here is the component velocity. So means the velocity here means the real velocity or the resultant velocity. So the resultant velocity can be calculated by using this equation. So you substitute everything, you will get it is equal to 12.37 meter per second. So and then I will not show the solution for this one. So you need to check whether it is rotational or irrotational. I think you know in my previous notes, I already give you 2 equations. One is you are using the value of psi. Okay, you need to have d square psi over dx square and so on and so forth. And another thing is you check the value of velocity because you need to know whether the velocity it is the value of zeta. Okay, the value of zeta is equal to 0 or not equal to 0. So if equal to 0 here, so it is irrotational. So if it is rotational means the value is not equal to 0. Why it is not equal to 0? Because to rotate the molecule, so you need energy. So it means that the zeta there is not equal to 0. So I hope you could check the tutorial, the previous note, so and solve this question. So we go for tutorial number 13. A source with the strength of 2.8 meter square per second located at origin is combined with a uniform field with free stream velocity of 1.6 meter per second. The uniform flow is in positive x direction. Draw the combined flow field pattern and determine equation for the stream function for the combined flow field, radial velocity and tangential velocity of the combined body. Radial coordinate of the stagnation point, maximum width of the combined body, resultant velocity at P negative 0.8 and 3.0. So you know that we have a source here. So and then we have the linear uniform field here. So mean we are discussing about Rankine half body. Okay, so this is the flow field pattern. So what you need to understand here is you need to understand about the x direction. So the x direction means it is flow from left to right. And then you need to draw clearly the stagnation point here. And then you could draw the velocity, the direction of the linear flow. So if it is good for you to draw the source like this one. But if you not draw this one, it is still okay. Because in certain textbook, it will assume that this is actually a solid body. So it is okay not for you to draw what happened inside the Rankine half body. Okay, so the combined stream function, so it is the combine the positive linear and the source. And when we check the value of side combination, we know that it is equal to m over 2. So, and then the component velocity, so you just write this one. So you derive it from a Cauchy-Riemann equation, and then you get each terms. So, and then to calculate the coordinate for stagnation point, so the rule of thumb, the basic idea is you need to assume that the velocity is equal to 0. So when you do this equation, so you assume that u theta is equal to 0, and then you will have it is negative u sine theta. So mean for negative u and sine theta here, the only possibility to this term equal to 0 is the sine theta will become 0. You cannot assume u will become 0, because if u is equal to 0 means there are no linear flow. So means if there are no linear flow, means the Rankine half body, it will not exist. Okay, so jadi kita beranggapan hanya sin theta sahaja yang akan menyebabkan had laju menjadi kosong. Oleh itu sin theta kosong berlaku pada 0 darjah dan juga 180 darjah. So and then to calculate here, okay, so and then to substitute with theta is equal to pi into this equation, into the UR here. So we get R is equal 0.27 at 5 meter here. So and then if you want to write down the coordinate of stagnation point, you need to write like this one. 0.27 at 5 is actually the distance from the center of source to the stagnation point. So means, let's say this is the center of source. So the 0 point here, so this is the value of R. So this R, it is equal to this value, 0.27 at 5 meters. So in coordinate, you need to write like this one. And width of Rankine half body. So you know that, so this we have a Rankine half body here. So Rankine half body width mean asymptote times 2. But from our previous notes, we could calculate the value of y asymptote here by using this equation. Okay, please bear in mind that y asymptote here is actually the distance on y-axis. So mean a vertical distance. And r here mean the distance from the center to the combination line. So mean the value of r here will vary. So jadi we use the idea of r sin theta here. So r sin theta is equal to y. So and y asymptote occur at theta menghampiri kosong. Kerana apa? Semakin kecil angle di sini, okay, akan menyebabkan nilai y asymptote semakin tinggi. Jadi setelah awak masukkan nilai theta menghampiri kosong, so we get r sin theta, it is equal to 0.875 meters. So if we times 2 to get the width, so it is equal to 1.75 meter. So and then a resultant velocity at point negative 0.8 and 3.0. So you just imagine this one in Cartesian coordinate. So we have negative 8 here and then 3. So we just assume that the half body Rankine is something like this. So this is the coordinate of negative 0.8 and 3. So what we need to do is please calculate its location first. So in our side combination, we are expressing the terms in polar coordinate. So means you need to know what is the value of r and what is the value of theta. So I hope you could imagine that if we have a coordinate here, So you could calculate what is the value of r here and what also the value of theta. So the value of theta is here. So and then we substitute into the velocity component equation from Cauchy-Riemann equation, and finally we could calculate the resultant velocity here as 1.75 meter per second.